Hello, everyone. Today we are going to talk about solving absolute value equations by graphing. So, before we get into how we can solve absolute value equations algebraically, which, by doing some math like you would have solved a linear equation or something similar, we're going to talk about what this looks like on a graph because I think it helps us wrap our heads around what's going on here. So, let's dive right in. The solution or solutions to an absolute value equation are the values of x that make the equation true, right? So we take these x values, I plug them back in, and it's going to pop out a true statement, just like before. Graphically, though, these solutions are the x-intercepts, or x values actually is the better answer there because I'm going to be more specific. So the x values where the absolute value function intersects with a horizontal line. So I'm going to show you what it looks like if it's set equal to 0, but also a lot of times it won't be. So that's why I changed that to x values. So and this, of course, is I'm going to put in simpler cases. It could be that we have not a horizontal line, but like a linear function, like a diagonal line crossing with our graph as well. So let's see, though, in these simpler cases, what can happen here. So I want you to think, how many solutions can an absolute value equation have? Okay, so like sketch a V shape. How many times do you think you can cross that with the horizontal line? All right, so there's going to be, three different answers here. So those are my lines. So we can have a horizontal line. This is probably what you first thought of. That intersects twice, right? So it can happen twice. It could happen once. Just gonna draw my line here. Once. Then I'm actually gonna move this one a little bit. It could be that they don't intersect at all, right? So there could be, right, uh, that there's one solution, no solutions, or two solutions. Usually is the case. So let's look at solving by graphing here. So we're going to do this in kind of 3 steps. Right, so the very first thing we're going to do is graph the left-hand side here. We're going to graph that x minus 1, absolute value of x minus 1. So we know that that minus 1 is moving our graph right 1. And then it has that typical slope, right? Like up 1 over 1 or down 1 over 1, depending on if you're looking at the left hand or the right hand side. All right. Now we're going to graph y equals 2, that horizontal line. Okay, so y equals 2 right here. And so this is the line. Y equals 2. And then we're going to look for points of intersection. So where they cross over. And so they meet here, and we want to know the x values. We know the y values for those points. It's 2. And so that's happening at x is -1 and x is +3. So then we just write our solutions like this. X equals -1, comma, 3, since there can be 2 of them. Alright, so next one. Following the same thing, we're going to graph the left-hand side and right-hand side separately. So we'll start by graphing negative absolute value of x plus 5. So that plus 5 moves my graph, shifts it up 5, and the negative outside the absolute value reflects this in the x-axis. So this is flipped over like so. Alrighty, so now we're going to graph that right-hand side. 3 y equals 3. And we're going to look for those points of intersection. Alright, so it's going to be when x is -2 and x is +2. And because, unlike the problem before, this graph hadn't been shifted left or right at all, notice the symmetry there, right? The -2 and the +2. Well, I guess -1 and 3 are symmetric, just about. This y is 1, or x is 1 here. Alrighty, so a little bit different of an example. And I have given you a graph, and you're going to tell me where these guys intersect. Alright, so hopefully you notice right there and right there. So that's -11 and 1. Alright, so now we're going to talk about graphing, and I'm going to show you both how to do it in a TI-84 and the Desmos. So we can also solve by graphing with technology, which is exciting. So how to graph in your graphing calculator is going to press that y equals button, and that is going to pull up this screen right here. And you're going to put in the left and the right-hand side of your equation, just like we had been practicing on the front page with graphing. So here, this would have been like the left-hand side, this is right-hand side. So I am going to press the buttons zoom and then the button 6 to bring up what's called zoom standard, and it graphs from it gives you a screen that goes from -10 to +10 on both the x and the y axes, so you can get a good picture of what's going on. If you hit second trace, and it will bring up this screen right here. We want to use the intersect feature, and that is going to help us to find the intersection points. And so it'll bring up something that looks like this. So this is our graph here. When I press graph, this is what we're going to see. And then here, I have found the right hand intersection point by hitting enter 3 times. Now, if I wanted to find the one over here, what I'd have to do is go through this same 3 steps here, right? Second trace, and then select this intersect, number 5. But I would have to hit my right arrow key, or my left arrow key, excuse me, to move closer to this intersection here, and then hit enter 3 times again, and then it'll give me this intersection here. So working with the TI is a little bit more involved, and I know some of you, that might be what you're using in the classroom, but it can be pretty expensive too. So I like to also show how to complete this on Desmos. So let me pull Desmos back up here. And Desmos is a little bit simpler and faster. So I'm just gonna squeeze my notes here a little bit. All right, so we've got plugging in, same thing. We're gonna do y equals the left-hand side. So in this case, negative. You hit the absolute value button. See, we've got all the common functions right there. You don't have to go looking for the absolute value button in the calculator. It's just under math, by the way. So you hit the math key on the TI, if you don't know, and then you hit over to number, you hit the right arrow, and then it'll be right there, absolute value. So, anyhow, we're plugging in the left-hand side of this function. So we got negative x, or absolute value of x minus 2 plus 3, and over here, I'm going to type in 2 Desmos, y equals 2, excuse me. And then Desmos color codes for us, which is just beautiful. Makes it easy to zoom, and so I can even just click right there. It says, hey, if you look, if I click on this, it shows you some gray points already. It's like, hey, I bet you want to know these values here. And sure enough, we do. So just like that, I could pull up those solutions. So for this graph here, whoa, craziness. We've got x is equal to, pull those back up, 1 and 3. All right, and then let's do another one. So just clear those out. We're going to do the absolute value of x plus 1 plus your absolute value bar minus 4. And over here, we'll do y equals negative 2. Right, so you can just zoom by pinching the screen. And again, same thing, it's going to say, hey, I bet you want to know where these guys intersect. And of course we do, and that happens when x is negative 3 and x is 1. All right, folks, so I hope that you enjoyed this deep dive into solving absolute value equations by graphing. And next time we are going to solve by using some algebra, good old inverse operations.